Hey guys, Mr. Adamson here. Welcome to another lesson in Science 14. Today's going to be a pretty quick lesson. We're just going to talk about heat and some of the terms that are associated with. When we talk about heat, one of the first things that we relate to heat is friction. And when two surfaces are rubbed together, the parts that touch resist movement. And this resistance, and it's kind of over, says right there, is friction. Now what this picture shows is that the box wants to move in this direction and it's moving against the ground, but you have friction resisting against it. So it's pushing, as you can see in the white line there, against it. And friction is a force that acts in an opposite direction of movement. So anytime you're moving something, it's not just, if you're moving it through the air, you have air resistance, just like your vehicles. When you talk about aerodynamics, there's always friction out there. The only places that you're not going to find friction is space. Because you don't have that air resistance, you don't have air out there to resist your movement and stop you from going somewhere. Now, Brownian motion. And Brownian motion is the movement of molecules. And this theory was developed by Robert Brown. And Brown suggested that the energy that came with heat, so thermal energy, was related to the motion of molecules. And so what this kind of shows here, this picture right here, is that each collision between two particles, or the walls of the container, so we're looking with right in here, and the forces of attraction between them determine the direction of path of the particle's motion. Now the random motion caused by the collision of the particles within the box is called Brownian motion. And again, Brownian motion is just the movement of particles, so anything that's kind of moving, any particles, it's the movement of particles. Now another term to be familiar with is kinetic energy, and we'll deal with kinetic energy way more when we get into some other physics units, but kinetic energy is a form of energy associated with motion, and it is a measure of the amount of motion particles have. So Brownian motion is a movement of particles, and kinetic energy is a measure of the amount of motion the particles have. Now the motion of particles can be compared to bumper cars at a fair. Like bumper cars, atoms and molecules collide with each other at different speeds, and all particles have different kinetic energies. Now kinetic energy can be used to explain the difference between heat and temperature, and we'll see that in the next slide here. So heat and temperature. Now if we just look at our few definitions here right at the bottom, temperature, so right here, is the average of all kinetic energies of the particles in an object. And the key word here, average. Now the temperature of the water in both of these beakers is the same because it's the average of all kinetic energies. And it doesn't matter if you have 25 milliliters or 100 milliliters. Now heat, though, is the sum of all kinetic energies of particles in the beaker. So the water in this beaker has more heat than the water in the beaker on the left. And so we can see here also that this beaker here has less kinetic energy than this beaker here. And we have more water within this beaker. Oops, that's a horrible looking arrow, sorry. So more water in this beaker here, and so again we have more heat because it's the sum of all kinetic energies. Again, if we go back a slide, kinetic energy is a form of energy associated with motion. So it's the measure of the amount of motion particles have. And if we look here again at this one right here, we have more water within this beaker. So we're going to have more kinetic energy. So heat is the sum of all kinetic energies. Whereas this one here, temperature, it's the average, and we're going to have less kinetic energy because we have less water. So there's just some terms to deal with today about heat. So Brownian motion, friction, heat and temperature, kinetic energy. Hope you're able to learn a few of those and make sense of them. And that's it for now. Thanks for listening.
Made with Doodlecast Pro.